stop. Make sure. Hello, 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 hello. How's it going? Make sure we're all live. There's quite the extra delay from YouTube getting on here, but we will give it a second here. Second, my phone's still not updating yet, so I don't want to get rolling yet. There we go. There I am. There I am. Hello, hello. Make sure you got sound. There we go. Good stuff. Good stuff. Hello, hello, everybody. Hello. How's it going? Whether you're with me live or on demand, I want to kind of go over this aspect here. Hello. Hello. Yes. Um, I hope everybody is doing well. Hope everybody is doing well. Everything's going good. Like I said, it's April the 20th. April the 20th, 2020. Good grief, we're already in April, right? We are already in April. That's kind of odd to think that, even with everything that's going on. Um, kind of odd in its own right, but you cool cats and kittens, yes. Hello, hi. How is it going? How's it going? Get started here in just a second. I want to kind of go through, I want to kind of get started here um, in a in kind of a review sense of things to kind of be able to show kind of correlate rate to slope to dealing with aspects of a line. I kind of want to get through that part of things, but to do that, you have to kind of, especially in this kind of aspect, kind of bear with me a little bit here. Um, let's take a look. Let's take a look here. So if you have this question in front of you, that says a group of college students developed a solar powered car and entered it in a race. So the car, so this car here, our little car here, our little car travels at a constant speed. So a constant speed. I can't, I don't know if I can, you know, put the emphasis on constant speed enough there to where be able to say it travels at a constant speed of 100 meters per 4 seconds. So 100 meters per 4 seconds. So here's the thing. It asks you, and it says, well, what representation can show the distance the car will travel over time? How can we show the distance the car will travel over time? And one way we can do that is by creating a graph. Ooh, a graph. We can create that graph. Okay. The reason I have underlined constant speed 4,000 times right here is because you want to be able to find out first what's the rate of that car that's traveling here. So what is that rate that car is traveling? How many meters per 1 second is it traveling? If you take your 100 and divide by 4, you will find out that the car travels at 25 meters per second, right? 25 meters per second. We can then take that and transfer it over to a graph. If you guys remember this from before, I think we used a pizza example with this, where in this instance, if that car, when it is at its beginning, how fast, and how far does it travel? If it's at its beginning, it travels a big fat 0. It travels nothing with that. So our bottom axis, our x-axis right here, is going to be how many seconds of travel, and again, bear with my writing as always here, seconds of travel, and then our y-axis here is going to be the distance. So if I can try to, it's not me craning my neck here, but your distance, your distance that gets traveled. For every second, so for every second that gets traveled, it goes 25 meters. 2 seconds, it's going to go 50. And again, if you were to label these as 25, 50, 75, got to bear with me on the writing on that. But again, it's a constant speed. So after 1 second, it travels 25. 2 seconds, it's 50. 3 seconds, it's 75. 4 seconds, it's 100. 5 seconds, it's 125. If you notice, that line is a straight line. You have to kind of bend your mind here, but that line is a straight line. That line is a straight line. What's up, Nick? So that line is a straight line because it is a speed. It travels the same speed, the same rate. Here's the thing. If I were to ask you and I were to say, well, how far would this car travel if or after 35 seconds? So after 35 seconds, okay, I don't think we want to sit here and draw out a line that's going to take you 35 seconds all the way over. You could technically do that, but here's where we have to kind of then bridge the gap here and be able to sit here and say, well, if you remember, there's an equation. Y equals, and this is going to be kx, but we're going to turn this into mx here in just a second. K is what we call the constant of proportionality. Constant of proportionality. Yeah, it's a fancy word for saying what is our rate that we're using here. That is what K is. Constant of proportionality is what K is. We found out that K is 25 in that instance. We can then take 25 and substitute it in for K, and then take that number times 35. And it works like that for however many seconds because it's a constant speed. It's a constant speed. So let me kind of clear this off for just a second. And here's where we have to then say, a constant speed, y equals kx, you have to kind of bridge this and realize that just because we went over this, k can also be slope of that graph we create. That slope, the slope of the graph we create right here, of that line. It's the same thing. K and M, your constant of proportionality, and your slope, K and M are pretty much the same thing. So we can then take, to define slope, those of you who remember this, if I take an ordered pair, here, 2 points on that same line. So say I had a point here and a point here. Trying my best here. Point here and a point here and a point here. You can be able to find the slope of the line. You find that the slope is also the same thing. Okay. Kind of making sense out there. Again, what expression can show the distance the car will travel over time? So the expression, like we just said, find out that the expression is y equals 25x. So you can fill in however many seconds that car is traveling to be able to sit there and say, well, how much, how much is the total meters that gets traveled? Okay, if that makes sense. And I'm kind of going around with things here. Again, and then compare the representation and the expression, which shows the distance traveled over time more clearly. Obviously, the graph would be easier to see, but you can also use the expression as well too. Just kind of trying to make the correlation between seeing 2 points on a line. Remember, it's going to be K equaling M on that instance right there. Needless to say, let's get into this. I am actually going to be getting into those packets you guys had received. Looks like I froze. Huh, interesting. I'm going to be getting into these packets. I'm going to kind of be focusing with topic 2. So topic 2 in this instance. Again, bear with my nauseating scrolling here because it's going to take me a second to get there. Let me get myself kind of opened up as well. So let's do a little vocab. Let's do a little vocab review here. I am on the front part. This is topic 2. I'm on topic 2. I want to kind of go straight into vocab because this is going to kind of help as we kind of continue going through with this. So the change in y divided by the change in x is the blank. Those of you remembering me banging on the screen and kind of focusing how to find slope of a line and saying it's the change in y over the change in x, and tapping on that and hitting that board many times, being able to find that slope of that line will kind of hopefully you can kind of chuckle in that instance right there. So the change in y divided by the change in x is going to be the slope of the line. So let's start with this. The slope of the line. That's the slope of a line. I'm going to kind of try it this way and say, I'm going to underline and then draw. Instead of me writing looks like a 2-year-old drawing these, probably 2-year-olds can draw that kind of better. So slope of a line would be in number 1. So the point on the graph where the line crosses the y-axis. If you knew nothing about this, you can kind of use your ELA, your ecology here, and be able to kind of figure this out by just kind of saying, well, the point on the graph where the line crosses the y-axis, I believe, would be what, if anybody follows football, would know what that would be, the intercept of the line. So when the line crosses that y-axis, remember that when a line crosses that y-axis right there, this point is what we would call that y-intercept, and that's where you would have your example right here. And you draw something like this, and draw that line to show where it's crossing that y-axis. Okay. Number 3. So the blank of a line is y equals mx plus b. The variable m in the equation stands for the blank. The variable b in the equation stands for the blank. Ladies and gentlemen, the slope-intercept form, remember, of a line is y equals mx plus b. The variable m in the equation stands for the slope. We just talked about the k equaling the m. It's the slope, stands for the slope. The variable b in the equation stands for the y-intercept. So it stands for the y-intercept. And again, I mean, if you were to draw an example, it's just being able to sit there and, being able to sit there and say, well, if I had 2 points on a line, I had 2 points on a line, and if you change the rise over the run would give us our slope, rise over run. If you remember that, rise over run will give us our slope. Okay. That's just kind of giving a little bit of that vocab to kind of refresh our terminology here on that front page. Get caught right here. We kind of clear this out and kind of just continue down. So let's do this. Let's get to. We'll get to this other part of this, more of this stuff tomorrow too. So I want to kind of focus here on 2.6 and 2.7. So 2.6 and 2.7 here. 2.6, 2.7. And if those of you who were not with me last Tuesday, I started to go through some of this, especially topic 1. When I talk about the topics, it's 1 through 8. So this would be topic 2. I'm in topic 2, lesson 2.6. And again, these break down to where it gives you a quick review of what we're trying to talk about, as well as an example as well too. It's very nice how they break this down. I mean, this book does tend to use a lot of words to do this, but that's okay. I mean, it's good to connect. It's good to connect the vocabulary with math and all that kind of good stuff. So let's look here. Number 1, or the only one that we see here. So the graph shows the proportions of blue paint and yellow paint that Brianna mixes to make green paint. So you have to say, well, what is the slope of the line? Tell what it means. Just tell what it means in the problem situation. Now, when we want to find the slope of the line, we have to sit here and say, well, what is our change in y over our change in x? Change in y over your change in x. Change in x. Okay. So you want to pick 2 points on this line. 2 points on this line. Here's a little word of advice. Start at 0. Start at 0 right here. Start at 0 as one of them. Remember me talking about that. If you have a line that starts at 0, use that when you're trying to find slope. It makes it that much easier. You're then going to sit there and analyze this line that you're seeing here to find out where does this line. This is where I have to kind of bear with my drawing on this, just because of I'm doing this on the screen. You have to find out. You see where my pencil is right here. I'm going to kind of circle this. Well, the line crosses where x and y meet. So this point right here, and I'm going to take this off. The ordered pair here is over 6, and then up 5. And our other point that we have is 0, 0. Okay, is 0, 0. So you want to find your change in y. Well, your change in y, you're going to be taking 6 minus that. I'm sorry, not 6. What am I talking about? It's going to be 5 minus 0, because remember that this is your y. This is your x. So 5 minus 0 over your change in x. Your change in x is going to be 6 minus 0. Is 6 minus 0. So when you do this, your slope of the line is going to be 5 over 6. It's 5 over 6. So what that's telling you is that for every 5 gallons, so for every 5 gallons, we sit here sometimes and we say, well, what does this actually mean? We find out that our slope is 5 over 6. That's saying for every 5 gallons of yellow paint, so for every 5 gallons of yellow paint, Brianna's going to need 6 gallons of blue paint. So for every 5 gallons of yellow, she's going to need 6 gallons of blue. Okay, 5 gallons of yellow for 6 gallons of blue. And if you were to correlate this and then say going up another 5 and then over 6, it would meet the line, I believe, at 10, 12, 15, 18. You're finding that same change. To bring it over. Okay, I know it's kind of rehashing a little bit. It tells you finding slope. As I said, as many times as I correlated here, this is change in y over change in x. That's how you find slope. You take 2 points on the line, and you're going to use, so if you had 2 points, so say for instance, a question gives you and it says, well, 2 points on a line are 2, 3 and 12, 14. And the question is, well, what would be the slope of that line? So you say, well, what's the slope of this line? The slope of the line that if we're using these 2 points, if you're going to take your change in y over change in x, start with your y's. You're going to take 14 minus 3 over your change in your x. 12 minus 2. 14 minus 3 is 11. 12 minus 2 is 10. Your slope is 11 over 10. Okay. Again, you could sit here all day and write different changes of slope and all this kind of good stuff. You had 2 points on a line that were 3, 13, and the other one was 8, 42. And you're finding your change in your y, 42 minus 13 over 8 minus 3, and 42 minus 13 is 29, I believe, over 5. Well, your slope is 29 over 5. Okay, it just works the same way. It just works the same way with that. That's finding slope. Finding slope right there. Let me see what I can see if I can get into something real quick. So a mixture of nuts contains 1 cup of walnuts for every 3 cups of peanuts. Write a linear equation that represents the relationship between peanuts, which is x, and walnuts, which is y. Well, how many walnuts? If walnuts is your y, so if y equals, and in this instance it's mx, we're going to find our slope, our y over x. If walnuts is y equals 1 over your peanuts of 3x. Y equals 1 over 3x. Okay. Again, it's telling you what's y and what is x in this instance, so it helps you out there. It's taking the 2 numbers and being able to kind of attribute that to being, well, what's the y, what's the x, and finding your slope. Finally, if we want to then graph that line, if we want to graph this line of y equals 1 over 3, 1/3 x, You're going to start at 0 because you don't have anything yet. Your change in y, you go up 1 and then over 3. And that would be your line. Okay? Okay? That would be your line. Okay? Again, it's supposed to start at 0 and go to 3, 1, so up 1 over 3 to show the line there. Okay, hope it makes sense. Any questions? We'll go through more of this tomorrow. More of this stuff here tomorrow. Get right into it and just kind of continue. Any questions, reach out. Here, looks like it's actually nice outside and not snowing, which is always fun, always fun. Other than that, just let me know if there's any questions. With that being said, I will bid you adieu. Have yourselves a good day. See you.